check one, check one. Check 1.
We can use it to our
Check 1. Right. Good evening, everybody. Back again with our MCQ night program. After 2 days, neither last Saturday we did, Sunday yesterday we couldn't do. Back again. Today is the fourth day, which means we are finishing the last 10 MCQs of 2024 level paper. That is question number 30 to 31 to 40. 31 to 40. Last 10 MCQs. Right. Before we start, confirm me from your end. Can you all hear properly and see the board clearly? Your thumbs up. Yes. Hari. Hari ned. Hari. Sir, what's your real name? What do you think? I don't know. I also don't know. We are in the last set of MCQs of 2024 level. Last 10 O level, last 10 questions. I already sent you all the Google form link, as you all have done. I will discuss while discussing. I'll talk to you all. Hurry. Last 10 MCQs. Last 10 MCQs. Usually this last 10 MCQ are last bit again. Some general things, biosphere things, whatever section. Sometimes feel those things also hard sometimes. Last set. Other than that, what we go deeply today is question 35. There is something to go deep. Question 35. We'll go deep, a bit deep to deep. Plus question 37. Question 37. There's something to discuss. Some students, when they see graph itself, they are scared. Mehema, when they are turning the pages, if they see a graph question itself, they are scared. I'll discuss this deeply plus question 35 and then we'll go in the normal order. Right. Take question 35. Question 35. A light rectangular lamina 0.4 meter by 0.3 meter is pivoted at point O and two forces 5 Newton, 4 Newton are applied. 5 Newton, 4 Newton are applied on it as shown in the diagram. What is the moment of force? What is the moment of force? What's the moment? They are talking about moment. We'll quickly revise on moment. Moment is actually the turning effect. The turning effect of force is what you call as the moment. Let's take this. By applying a force, I can turn this. I can rotate it. The turning effect by applying force, you call it moment. Turning effect by applying force, you call it moment. How do you mathematically calculate the moment? How do you mathematically calculate the moment? Let's take you have a rod like that. Pivoted at that point. I'll take the pivot point as O. Pivoted at O. A perpendicular force F is applied. Why I tell perpendicular force? Can you see the force is perpendicular to the rod? It is perpendicular to the rod. Perpendicular force F is applied. at a distance d from axis of rotation. That is your axis of rotation. That is your axis of rotation. That's the axis of rotation. From axis of rotation at a distance d, a perpendicular force F is applied. Guaranteed rod will rotate. Practically thing, pivoted here, you apply a force there, guaranteed it will rotate, which means I can calculate the moment. How do we calculate the moment? Moment turning effect is equal to perpendicular force F multiplied by the distance there d. Moment is equal to Ft. M equal Ft. What's the unit of moment? What's the unit of moment? Unit is force comes in Newton, distance comes in meters, Newton meters. Does it have any proper direction? Is there any proper direction? Yes, there is proper direction. What's the direction? Clockwise or anti-clockwise? This scenario, force is applied upwards. Force is applied upwards, which means the rod will be rotating. Rod will be rotating that direction. Rod rotates that direction. Clockwise, the anti-clockwise. Here, anti-clockwise. Here, anti-clockwise. So two directions are there, clockwise or anti-clockwise. Here it is anti-clockwise. Two important logics. This is the logic. Okay? Two important logics. Number one, let's take, you have a rod. You have a rod pivoted there. If you apply a force, at the pivot point, applying the force at the pivot point. If you apply a force at the pivot point, will it create any rotation? Practically think. Force applied at the pivot point, will it create any rotation? No. Think, rod pivoted, I apply a force here, is it rotating? For it to rotate, this force should be applied at a certain distance from that pivot point. Then only it will rotate. If you apply a force at the pivot point, it won't rotate. Point number one. Force applied at the pivot point won't create any rotation. Force applied at the pivot point doesn't create any rotation. Then will it create any moment? Will it contribute for any moment? No. Point number two. Point number two. Point number two. Let's take, you have a rod. Let's take, you have a rod. Pivoted there. Pivoted at point two. Pivoted there. If you apply a parallel force, if you apply a parallel force, why I tell it a parallel force? Why I tell it a parallel force? Rod is like this, force is like this, both are parallel. If you apply a parallel force, will it create any rotation? Will it create any moment? This is a parallel force. Will the rod rotate anywhere? Will it rotate anywhere? Again, no. Think, you have a rod pivoted there. I apply a force like this. Is it rotating? I apply a force like this. Is it rotating? For it to rotate, my force should be perpendicular. Perpendicular. Then it will rotate. If my force is parallel, will it rotate? So again remember, parallel forces, no rotation. No rotation, no moment. Keep those points in mind, and that's why we define this force as a perpendicular force. Perpendicular force will create moment. Perpendicular force will create rotation. Parallel forces won't create any rotation. Parallel forces won't create any rotation. Those are the important points. So again, one more time. Moment. Moment is the turning effect. How do you calculate moment? Moment F is equal, sorry, M is equal to FD. What's the unit? Newton meter. Direction clockwise or anti-clockwise. Force applied at the axis of rotation. Will it create any moment? Will it contribute for moment? No. Parallel forces. Will it create any moment? Will it contribute for any moment? Again. Sorry. With that logic, go to that question. With that logic, go to that question. A light rectangular lamina 0.4 meters by 0.3 meters is pivoted at point 2 and two forces 5 Newton and 4 Newton are applied on it as shown in the diagram. What is the moment of force applied at O? Look at the diagram. Look at the diagram. O, that is your pivot point. O is your pivot point. First tell me 5 Newton applied like that. That 5 Newton is starting from the pivot point. Starting from the pivot point. Applied on the pivot point. You take the lamina like this. You are applying the force here. You are pulling it from here. 5 Newton. Will it create any rotation? Will this 5 Newton create any rotation? Will it create any moment? No moment from 5 Newton. No moment from 5 Newton. Now come to the 4 Newton force. Look at the 4 Newton force there. Look at the 4 Newton force there. 4 Newton. Can you see 4 Newton force is perpendicular? 4 Newton force is perpendicular. Then will 4 Newton cause any moment? Will it cause any rotation? Yes. Harini. From here, you pull the rod from this direction, it will rotate. You pull the rod from downward direction, it will rotate. So this will create a moment. But to calculate that, you need the perpendicular distance between the axis of rotation and your force. This is the axis of rotation. That is your axis of rotation. This is your force. Between them, what is the distance? Between them, what's the distance? Don't tell 0.3 meter. 0.3 meter is this. We don't want that. We want the distance between axis of rotation and the force. That is 4 Newton. Sorry, 0.4 meter. That is 0.4 meter. So if I do the math there, my moment is equal to my moment is equal to FD. Moment is equal to what's the force there? 4 Newton multiplied by distance there 0.4 meter. That gives us 1.6 Newton meter. 1.6 Newton meter. What direction? Force is this way, rotation is that direction. Rotation is that direction. Clockwise direction. Rotation that direction, clockwise direction. So 1.6 Newton meter clockwise is your answer. That is your answer number 2. 1.6 Newton meter clockwise is your answer. That is. So remember what you learned from this, and that is what is important. Forces applied at the axis of rotation, no moment. Forces applied parallel to the rod, no moment. Only perpendicular forces that are applied at a certain distance causes moment. Sorry. That's your question 35. Come to question 37. 37. A sheet of zinc suspended on a spring balance is immersed in a hydrochloric acid solution. Zinc is immersed in hydrochloric acid. Zinc is immersed in hydrochloric acid. Right. Okay. Bringing them to react. Sometime after the beginning of the reaction, another quantity of the acid solution was added into the reaction mixture. If the spring balance reading is M, was plotted against time t, which of the following graph is most likely to be obtained, right? What are they doing? What are they doing? On a spring balance, on a spring balance, a zinc sheet is hang. A zinc sheet is hang. And they are slowly immersing it into hydrochloric acid. Zinc is immersed in hydrochloric. Tell me what will happen? Zinc and hydrochloric. Zinc and hydrochloric. Zinc is a metal. Zinc is a metal. Re- Reacted with hydrochloric is a acid. Hydrochloric is a acid. Metal plus acid. Metal plus acid. What will happen? What will happen? Metal, when it is reacted with acid lamine, two products are formed. Two products are formed. Salt of the metal plus hydrogen gas. Go open the mouth and tell. Metal plus acid. Two products are formed. Salt and hydrogen gas. Metal and acid, two products, salt and hydrogen gas. So here metal is zinc, acid is hydrochloric acid. What is your salt? What is your salt? How do you find the salt? Metal joins with the negative ion of the acid. Metal joins with negative ion of the acid. From there you get the salt. Metal is zinc. Negative ion of the acid is chlorine. Zinc and chlorine together. Zinc and chlorine together. Zinc chloride. Now chlorine is gone. Then who is remaining? Who is remaining? Who is remaining? Hydrogen. 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 That is what is released. That's your reaction. Now they are not asking reaction, but I'm covering every side I can. When I touch a question, I'm trying to cover every side I can. So zinc plus hydrochloric, zinc chloride plus hydrogen gas. That's your reaction. Now they are not asking reaction. What are they telling? Now when you hang it here, this zinc will have a certain mass. How it will have a certain mass. So when you immerse it slowly inside, when you immerse it slowly inside, what will happen to the mass of the zinc? What will happen to the mass of the zinc? Keep the graph aside. You logically tell me zinc is reacting with hydrochloric. What will happen to the mass of the zinc? Remain same or reduces? Remain same or reduces? Practically things, zinc is reacting with hydrochloric. Then what will happen to the mass of zinc? Zinc mass will guaranteed reduce. Zinc mass will guaranteed reduce. So now convert it into a graph. Now you know the logic, convert it into a graph. Mass versus time. Initially, zinc has a certain mass. That mass is going to reduce. That mass will reduce. But think about reactions. During reactions, reaction proceeds always in a linear way, or it will accelerate and decelerate. First, the second. Very linearly, perfectly with time it reduces, and Mehema it will reduce or the other way. First or the second. First or the second. Third loop. Ayyo. First or the second. Second way. Initially, zinc's reaction will be high. Slowly, its reaction rate will reduce. Initially, zinc's reaction will be high. So quickly the mass reduces, quickly the mass reduces, faster the mass reduces, faster the mass reduces. See, initially reaction rate is high, reaction rate is high. That's because the concentration is also high. So reaction rate is high. With time, that rate will reduce, reduce, reduce. So initially zinc's mass will vary like this. Somewhere there, almost reaction is trying to stop. Why? Maybe all the hydrochloric acids are consumed. Concentration of hydrochloric is fully reduced. So by somewhere there, reaction is trying to stop. Are they telling you are stopping from there? No. What's the question telling now? What's the question telling now? Sometime after the beginning of the reaction, another quantity of the acid solution was added into the reaction mixture. Sometime after, that means when the reaction is about to slow down, again they are adding hydrochloric acid. Now tell me, again when you put hydrochloric acid, what will happen to the concentration of the hydrochloric acid inside? Increases or decreases? Second time when you put hydrochloric acid, what happens to the concentration? Increases. When the concentration increases, again what happens to the rate of reaction? Goes flat. The nothing rate of reaction increases. The rate of reaction increases. The rate of reaction will increase. So it won't go flat now. Now again rate of reaction is increasing. If the rate of reaction again increases, what will happen to the mass of the zinc? Remain same or mass will reduce again? Mass remain same or reduce? Mass will reduce. So again same kind of graph will come. Again same kind of graph will come. Again same graph will come. So you double the graph twice. Again listen. Initially zinc has a certain mass. When you put it in hydrochloric acid, it starts reacting. As it is reacting, mass of zinc reduce, and now reaction is almost about to stop. By that time, again you are adding some hydrochloric acid. Thereby you are increasing the concentration. Thereby again increasing the rate of reaction. When you increase the rate of reaction, again the mass of zinc will start reducing. Again it will reduce. Let's take again they put some hydrochloric. Then what will happen? This curve how many times? Let's say 2 times they put hydrochloric. Now only 1 time they have added hydrochloric. Then how many bends will be there? This curve how many times? 3 times. Got it? Yes. That is for zinc. Sometimes in the exam they might ask you, draw a graph for the evolution of hydrogen. They might ask you to draw a graph for the evolution of volume of hydrogen. Evolution of volume of hydrogen. Then how can you draw? Now these are the logics you learn. I know maybe you would have been able to do this question. But what you learn from this, that is what is important. That's what you call paper discussion. They might ask you to draw a graph for the evolution of hydrogen. Go tell me, initially, do we have any hydrogen? Initially, at the beginning of the reaction, do we have any hydrogen? At the very beginning, no hydrogen, no hydrogen. So here, graph starts from bottom. Here, graph starts from bottom. Now, there, graph started from top. Why did the graph start from top? Because initially, there is some zinc. Reactant is there. Reactant reduces. Now we are drawing for product. Product, you start from bottom. Product increases. Product increases. How should I draw the graph? Go tell me. First the, second the, what can you tell? Nathan, third the. What type of graph I should draw? Mathematically tell me first the, second the, third the, what type of graph? See. From this graph, what did you understand? Initially, rate of reaction is high. Very quickly, the mass reduced and then slow down. Quick reduction, then slow. Here also then, quick increment should be there, slow. Which one has quick increment and slow? Quick increment and slow. First one. First one has quick increment and slow. First one has the quick increment and slow. Analyze this. Quickly increasing, going up. Quick increment and then flat. You might wonder, sir, then what about this one? Make. This one slow increment and fast. Slow and fast is only this graph. That one we don't need. Slow and fast. We want fast and slow. Fast and slow. That is your graph. Again, they are putting hydrochloric acid. Then how many times you have to draw this? 2 times. With that, let's take this top. Then what I should do? I should bring the graph upward, then I have to make it flat. Then. Make it. So again, you should be able to analyze. Hurry. Nothing hot, nothing hot, nothing hot. Hurry. Now going to our question. Your graph. That is your what graph? What's your answer? What's your answer? Answer number 4. Answer number 4. Okay. Hurry. Yes. Hurry. Right. Now we'll go in normal order. Normal order. Normal order. Question 31. Power of an electrical heat is 1000 watt. Power is 1000 watt. Power 1000 watt. Tell me that in kilowatt. 1000 watt. Tell me that in kilowatt. Just I'm asking. I was looking at the answer. All are given in kilowatt. 1000 grams. How many kilograms? 1 kilogram. Then 1 kilowatt. 1000 watt is 1 kilowatt. Right. The amount of electrical energy spent. They are asking energy. Electrical energy spent when the heater operates for a time period of 2 hours. 2 hours. Power I know. Time I know. Energy they are asking. Power I know, time I know, energy they are asking. What is your equation? What is your equation? What is your equation? Onnalamai, energy E is equal to PT. Energy E is equal to PT. Now look at your answer. Look at your answer. Look at your answer. Answers are in kilowatt hour. Kilowatt hour. That means my P should be in kilowatt, time should be in hour. Answers are in kilowatt hour. So P should be in kilowatt, time should be in hour. P 1000 watt, how many kilowatt? How many kilowatt? 1 kilowatt. Multiplied by time, how many hours? 2 hours. Then what is your energy? 2 kilowatt hour. 2 kilowatt hour. 2 kilowatt hour. 2 kilowatt hour is answer number 2. Answer number 2. Question 32. Which of the following metal can be used for cathodic protection of iron? Cathodic protection of iron. What is cathodic protection? When you keep iron in contact with a metal that is more reactive than iron. When you keep iron in contact with a metal that is more reactive than iron, then you can protect iron from rusting. That is cathodic protection. What is cathodic protection? What is cathodic protection? You keep iron, in contact with a metal that is more reactive than iron. Iron with a metal that is more reactive than iron, then you can protect the iron from rusting. This protection is called cathodic protection. Another name is there, sacrificial protection. Metal with another metal that is more reactive than iron, you can protect it. Tell me some metals that are more reactive than iron, which you can keep in contact. And sodium sodium we can't keep in contact. Magnesium, zinc. That's the answer. Answer for. Answer for zinc. Now, this question also some people didn't get right. Maybe the way they have given the question might be a bit confusing. Force exerted vertically upwards on a rocket of mass m due to combustion of fuel is R. And you have a rocket. You have a rocket. You have a rocket. Force applied upwards. Force applied upwards due to combustion of fuel. Force applied upward due to combustion of fuel is R. So it's burning the fuel, and from that creating a force, that force is R force. That force is R force, right? And mass of the rocket is m. If g is the acceleration due to gravity, the acceleration with which the rocket moves is, right? They are telling mass of the rocket is m and g is the gravitational acceleration. First, we'll mark the forces on this rocket. What are the forces on this rocket? Due to burning of fuel, R force is acting up. Is that the only force acting on this rocket? Is R force, upward force, the only force acting on this rocket? No. Other than this, what else is there? What else is there? Weight force is there. From center of gravity, weight force is acting down. How do you find the weight force? Mass of the rocket m multiplied by gravitational acceleration g, that is the weight force. So upward R force is there, downward weight force is there. So we know the forces. We know the forces acting on this rocket. F we know. F we know. And we know the mass of the rocket, m we know. What are they asking in the question, Lamai? What are they asking? The acceleration with which rocket moves is. The acceleration with which the rocket moves is. Acceleration they are asking. F we know, m we know, a we need to find. What's your equation? What's your equation? F equal ma. How do you apply this equation here? What are the forces acting on this rocket? Upward R, downward mg. How can I write it in F there? Upward R, downward mg. I should add mg or subtract mg? Add mg or subtract mg? Subtract mg. That is going to be equal to mass of the rocket. They are given m. Acceleration have they given? No. Acceleration we don't know. That is what we need to find. So if I need to find acceleration, I should subject acceleration. If I subject acceleration, all the other values goes to the other side. M on the other side become division. So if I subject acceleration, acceleration will be equal to R minus mg. M goes to the other side divided by m. That's your answer. Understood how to get this? Understood how to get this? Yes. Again, one more time, see. Again, one more time, see. Or is the force acting on the rocket, that is upward. Weight is however acting downwards. So you know the forces. You know the mass. They are asking you to find acceleration. F equal ma. If I apply F equal ma, force, what are the forces acting? Two forces. R force, mg force. R force is acting upward, mg force is acting downward. Opposite direction force you add or subtract. Opposite direction force you add or subtract. Subtract. So R minus mg equal mb. Subject A, m goes to the other side. Then A equal R minus mg over m. Okay. That is your answer number. That is your answer number. What's your answer number? Answer number one. Answer number one. Question 34. Question 34. Given in the figures are masses of four gases of hydrocarbon. In which of them equal number of molecules are contained? In which of them equal number of molecules? Which of them have equal number of molecules? Now let's take here there is 60 molecules. Somewhere else where there is 60 molecules. Or let's take here there are 40 molecules. Somewhere else where there is 40 molecules. Which two has equal number of molecules? How do you find the equal number of molecules here? Simple. Leave the molecule story aside. Find the number of moles in each situation. Here number of mole, here number of mole, here number, here number. Find the number of moles. We'll find the number of moles. Help me to find the number of moles. First, methane is there, CH4 is there. 8.0 grams. Second, C2H4 is there. 7.0 grams. Next, C2H6 is there. 10.0 grams. Finally, C3H8 is there. 11.0 gram. Right. We'll find the number of moles. We'll find the number of moles. To find the number of moles, we need the molar mass of each one of them. Carbon, hydrogen. Is there molar masses given? My molar masses are given. Carbon 12, hydrogen 1. From that, we can calculate their molar masses. 1 carbon is there 12. 4 hydrogen are there 4. Then molar mass is 14 gram per mole. From there, we'll find the number of moles. Number of moles is mass over molar mass. What is the mass given? 8 grams. What's the molar mass? 14. If I solve it, I get 4 over 7. 4 over 7. 4 over 7 mole. I'm not going to find the decimal there. I'll just keep it as 4 over 7 mole. Next, come to this one. Find the molar mass there. Molar mass there. 2 carbons are there. 1 carbon 12, 2 carbon 24 plus 4 hydrogen are there. 1 hydrogen 1, 4 hydrogen 4. Then from there molar mass is 28 gram per mole. Now we'll find the number of moles. Number of moles is equal to mass over molar mass. Mass is 7 grams. Molar mass is 28 gram per mole. If I do the math there, 1 over 4. 1 over 4 moles will come. 1 over 4 moles. Come to the third one. 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 මෙතන වරද්ද ගත්තනේ. මේ මොනවද මේ? 12 plus 4 16. So here you get 16. So you get half ned. You get half there. Yeah, you get half a mole. Next, molar mass there, 1 carbon 12, 2 carbon 24 plus 6 hydrogen 6. Then molar mass is 30 gram per mole. 30 gram per mole. Now if I find the number of moles is mass over molar mass. Mass is 10 grams. Molar mass is 30 gram per mole. That is 1 over 3 moles. 1 over 3 moles. Come to the last one. Come to the last one. Come to the last one. Molar mass. 1 carbon 12, 3 carbon 36 plus 1 hydrogen 1, 8 hydrogen 8. Molar mass is equal to 44, need 44 gram per. From there, if I find number of moles is mass over molar mass. Mass is given 11 grams. Molar mass is given 44 per mole. If I do the math there, 1 over 4 moles. Now look at all of them. First one, half a mole. Second one, quarter of a mole. Third one, 1 over 3 mole. Fourth one, 1 over 4 mole. In which one number of moles are equal? In which two setups number of moles are equal? This is A, this is B, this is C, this is D. In which two number of moles are equal? Tell me. In which two number of moles are equal? B 1 over 4, C D 1 over 4, 1 over 4, 1 over 4, BD number of moles are equal. If number of moles are equal, number of molecules will also be equal. Keep that in mind. If number of moles are equal, number of molecules, and listen to this, molecules and the words I'm using. If number of moles are equal, number of molecules there also will be equal. If number of moles are equal, number of molecules are also equal. So here number of moles are equal, 1 over 1 over 4. Number of molecules are equal, B and D. B and D. That's a time consuming question. Eh? See, question 34, somewhere there they have made you struct. Time consuming. You can't finish it in 1 minute. So that's why when you can do questions fast, quickly do that. Now some MCQs you don't need to waste time. Now for example, take 32, no need to waste time. 1 second you write the answer and go to the next one. So those questions you buy time. This question you use that time. Alright, don't unnecessarily waste time in MCQ questions. How? So that is B and D. Answer is answer number 3. B and D answer. Question 35 already done. Now going to question 36. 36. Boiling point of hydrogen chloride and water are 85 degrees Celsius and 100 degrees Celsius respectively. Which of the following statement explains the cause for this difference? Remember, boiling point is due to what? Intermolecular forces. Keep that in mind. Boiling points are due to intermolecular forces. Boiling points are due to intermolecular forces. Intermolecular forces only contribute for the boiling point. So here different boiling points. Why different boiling point? What difference is there? Intermolecular forces are different. The intermolecular forces among hydrogen chloride molecules are weaker than intermolecular forces among water molecules. That's the correct one. Remember, when they talk about boiling point, answer is guaranteed intermolecular forces. Intermolecular forces will talk about boiling point. It only decides the boiling point. Keep that in mind. Boiling point is decided by intermolecular bonds. Okay. Question 37 already done. Last 3 actually biosphere question. I swear this is a general one. Of the following, which one is false statement? Which is false statement? Which one is false statement? Acid rain occurred due to release of chlorofluorocarbon to the atmosphere. Wrong. Acid rain are not due to chlorofluorocarbon. Remember chlorofluorocarbon, CFC. It causes what? One, global warming. Two, ozone layer depletion. Tell me, chlorofluorocarbon causes what? Global warming, ozone layer depletion. Those are the two caused by chlorofluorocarbon. Global warming, ozone layer depletion. Acid rains are not due to chlorofluorocarbon. Ehinang tell me, acid rains are due to what? Acid rains are due to what? Acid rains are due to sulfur dioxide, sulfur dioxide, sulfur trioxide, nitrogen dioxide. Again, tell me, acid rains are due to what? Sulfur dioxide, sulfur trioxide, nitrogen dioxide. Not chlorofluorocarbon. That's wrong. Greenhouse effect is necessary to maintain life. Yes. Greenhouse effect affects global warming. Yes. Oxides of nitrogen affect depletion of ozone layer. Yes. Ozone layer depletion due to chlorofluorocarbon and nitric oxide. Keep that in mind. Ozone layer depletion is due to nitric oxide and chlorofluorocarbon. Acid rains are sulfur dioxide, nitrogen dioxide. Ozone layer depletion is due to nitric oxide, chlorofluorocarbon. That's correct. Answer is answer 1. 39. Which of the following disaster condition has the minimum influence of human? Human is minimally influenced. Minimally influencing. Human's influence is very minimum. What? Occurrence of tsunami. Need. Can you create tsunami? Can you create a tsunami? Where I will go today and create a tsunami. Can you go and create a tsunami and come? No, you can't. You can't. Occurrence of photochemical smog. Yes, human influence is there. Vehicle smoke. Spread of invasive alien plants, invasive plants. Maybe due to your improper irrigations or reconstructions. Yes. Invasive invasion of settlement by wild animal. Why elephants come and destroy the houses? Because people are going and building houses in the habitats of elephants. So they have human influence. First one is no human influence. In a traditional tank, what is the structure that prevents the erosion of tank? Bunt. Pralapanav. Yeah, direct theory. This is history, no? History is also there. Biosphere. In science also we have. Okay. Now what about carbon monoxide, carbon dioxide for acid rain? No. Carbon dioxide, yes, it causes the rain acidic. The carbon dioxide doesn't specifically cause acid rain. Mixing of carbon dioxide in the rain causes the normal rain to be acidic. In the acid rain, I have taught. Carbon dioxide doesn't cause acid rain. Acid rain is due to sulfur dioxide, and nitrogen dioxide. Yes, carbon dioxide is there. Due to dissolution of carbon dioxide, rain become acidic, but that rain is not considered as acid rain. Carbon dioxide dissolved rain is not considered as acid rain. Our normal rain, that is obviously acidic. Normal rain is pH 5.6. Normal rain is itself acidic. It is not considered as acid rain. For the rain to be acid rain, there should be sulfur dioxide, and nitrogen dioxide dissolved. Okay. That completes us. How many questions? 40 questions, right? 40 questions. That is your 2024 O-level paper. 2024 O-level paper is done. Now one full paper is fully done. One full paper is fully done. As a homework, what I want to give you all is, now take the full paper, 2024 full MCQ paper, sit and do the full paper. Now don't take exactly 1 hour to do. Within about 20 minutes you can do. Now we have discussed everything with the logics you do. No memorizing and doing with the logics. Now this is this, this is this, this is this. With the logics you again one more time. Don't waste time. Within about 20 minutes, 20 minutes with the logics you do. This is. Right? One time do it. And tomorrow we are starting new paper, that is 2023 O-level paper. So with that, our 2024 O-level, again, last year O-level MCQ paper is done. Right? Those who wrote reviews of today's one also send me. Additionally, the question I ask you, 2 days are gone. 2 days are gone. I met you, and today 2 days are gone. Question is, how did you use your previous 2 days? Today and yesterday, no? 2 days. How did you use your 2 days? Answer is for you. You don't need to answer me. Did you use it in your maximum way, maximum level, giving your maximum capacity, or did you waste it? Answer is for you. Answer is for you. Did you give your maximum there? Don't think that this is my normal level. I can't go for a maximum. I don't have a maximum inside you. Don't keep fooling yourself. You have a maximum inside you. If you didn't give it, regret is for you. Now, nothing to do about that. Nothing. We can't reverse it. Whatever gone is gone. This second, gone. It's gone. We can't reverse that. So whatever gone is gone. We can't reverse. We can't do anything on that. Work for the next. Work for the next. Work for the next. By now 50s day count. I told you don't take February. 50s days count. Now give your best. Hurry. At the end, 2024 O-level paper is done. 2024 O-level paper is done. 40 MCQs are done with discussion. With discussion. At the end of 2024 O-level MCQ paper, I ask you, now what do you feel about MCQ questions of 2024? Everyone together. What do you feel? What do you feel? Everyone together. What do you feel? Letter by letter, one by one. There you go. Letter by letter. Start. P, P. Next, next. A. Next, next. T, next letter, another T, last letter, there you go. A, next set, E, next, A, last two, S, last letter, Y. PattaEasy. Don't forget the hashtag, the signature. This is for our 2024 O-level paper. Done. Right. Hare Hina. Tomorrow meet you all with 2023 O-level paper. I want your best when I meet you. Keep working. Bye. Good night.